One of the big topics in every supply chain is to serve the customer with the best service level. And of course, you can stock your finished products really close to the customer, really high, but you piling up inventory. And this is, of course, bound capital. It means you have capital against service level, and dependent on the year, you will, if you work in supply chain, in one year it's all about service level, in the next year it's all about inventories. Inventories is always a topic, and inventory optimization is always linked to analytics itself. So let's have a look, where is it really embedded, inventory optimization. When we look again on our supply chain matrix, inventory optimization is really playing a crucial role from supply network planning, master planning, production planning, distribution planning, and purchasing. Here you can see that it's really distributed how to ensure a good balance on so-called your stock levels in the entire network. And this is also the complexity. The problem is really distributed about subsystems, and there's normally not one single function responsible for the inventory. And this is really a big challenge. When you start with inventory optimization, it's mostly about two fundamental questions you have to solve: where to stock and how much to stock. If you speak about where to stock, that means you can stock maybe really close to the customer, or you can stock somewhere in a regional really big cluster. You could stock at the end of a factory, between two factories. You can stock as well so-called raw materials at the supplier level. And this is really the point. So do you have to decide where to stock? That's a bigger strategic topic. And then on each of these stocking points, how much to stock. And this is called supply chain parameterization. Let's start with how much to stock and how the so-called replenishment cycle is typically done. This is really a very simplistic so-called reorder point logic. That means you see here a curve which shows your inventory in hand, maybe at one location, and the curve is going down. That means you're consuming parts of your products from stock. It's getting less and less. Then it goes below a certain threshold and you release an order and says, okay, please deliver again 1,000 pieces. And then the order quantity comes in, then you are at a high level of your stock level, and then it's going down again. And then you have here a very frequent pattern, which would be quite stable, how to handle it. The reality is, of course, way more complex. The slope of the so-called consumption of the inventory might change. This is maybe here indicated. So you start with a normal slope, that's the consumption of your inventory, then you order something, and then maybe the slope changes a little bit. I don't know if you can see it here in the picture, but it changes. And then you're a little bit too late if you just have this reorder point, and then you go maybe below zero stock, and this is called out of stock. That's the red cycle. And then, of course, you rush into new orders, and maybe you order twice as much as usual, and then maybe you have stocked too much, because remember, if you are stocking too much, either you get into space restriction or again this kind of bound capital. That means if you look on this chart, you see these two critical points: ordering too late or ordering too much. When you look on this picture before, sooner or later you always will end up with a so-called economic order quantity. That means this is a kind of you can calculate how much to order. That's really balancing the inventory cost against service level. This is the final formula. This is a very old formula already. I think it was developed in the early 20th centuries. And it takes as input the total annual cost and the purchase unit price and unit production cost. These two things are not in the final equation because you're searching for a minima. You can look it up in the Wikipedia. It's really classical. It's classical how to derive it. Finally, you have order quantity. You have here a star with an optimal order quantity. from the optimal order quantity, you have to derive the order quantity because you have maybe other constraints. And then in the formula, you still have the annual demand quantity. How much really do you need in the year? How much is the fixed cost per order? And how much is the annual holding cost per unit? So if you have this kind of input information in a perfect way, it gives you at least a kind of thinking how much you should order. And derive from them and the slope and your forecast, you can derive as well your minimum stock quantity. The idea behind is very simple, and I think in every system in the world, and everyone is establishing this as a basic starting information. The challenge is that you just optimized one point, and if you look on the full supply chain, it might be that different points have a different way of ordering. And if you look on the full systems in the background, I indicated here with thread, you have more or less many different things you have to configure or to parameterize in your system. So, and this is exactly where your stocking point analytics starts and where really you can harvest a lot. In fact, you're playing master of puppets with your systems by bringing in the correct parameters to all your planning elements in your systems.